Parametric curves video 6. Video 7. A curve has parametric equations x equal 3t squared minus p, y equal 3t cubed, where p is a non-negative constant and t is a real parameter. State in terms of p the range of the values of x. Part A. Part A. In terms of p, we have to know what are the values of x. First, x equal 3t squared minus p. This means that x plus p is 3t squared. 3t squared is t squared is positive or equal to 0 times 3, so it's positive or equal to 0 value. This means x always greater or equal this positive value p, non-negative value p. So what are the values of x? X goes from exactly p to plus infinity, right? To plus infinity. Minus p, sorry, because we take p to the other side, it should be minus p, right? So it goes from minus p to plus infinity, right? Taking p to the other side of inequality, it gives me minus p. Part B, express dy over dx in terms of t. So dy over dx, we know that it's y prime, which is x dot y dot over x dot. X dot equal 6t, y dot equal 9t squared. This means y prime, which is equal to dy over dt, equals to y dot divided by x dot, which is equal to 9t squared over 6t, and it will be 3 divided by 2, simplifying by 3, t squared over t, it's t. Part C, find the gradient of c at point minus p0. What's the meaning of minus p0? Point minus p0. If we put instead of x minus p, right? X minus p0, this is the abscissa and this is the ordinate. This gives me t equals 0, right? T equals 0. At this point, if we put instead of x minus p equal 3t squared minus p, that says that 3t squared should be equal to 0. This means that t is equal to 0. At t equals 0, we have x dot will be equal to 0, y dot will be equal to 0. Part D, sketch C. Sketch C, let me copy again the parametric equations. Copy, not cut, right? Now, we have the domain, right? Which is t belongs to minus infinity plus infinity. Directly the limits of x of t as t approaches negative infinity, as t approaches negative infinity, as t approaches negative infinity is equal to positive infinity, and limit of y of t as t approaches negative infinity is equal to negative infinity. So positive infinity to abscissa, negative infinity to ordinate. It's from south east, right? It's southeast corner. And the limit xt as t approaches positive infinity, limit of yt as t approaches positive infinity, both gives me positive infinity. So it ends with, it terminates at northeast corner, northeast corner of the coordinate system. All right, y prime, we found it. and it's 3 over 2t, right? We already found it. Y prime is negative when t is negative. Y prime is positive for t is positive. If t is negative number, 3 over 2 times negative number is negative, and if it is positive, then the derivative is positive. And the derivative is 0 for t is 0, right? If t 0, the derivative is 0. Hence, the stationary point, we have stationary point at minus p0, right? And this stationary point for t equals 0, substitute t equals 0, x will be if t0 minus p, and y will be 0. Stationary point, at this point, this means we have a horizontal tangent, right? A horizontal tangent at that point. Let's see. Or maybe tangents. Let's find the y second derivative. So x2 dots is the derivative of x dot. X dot was 6t, so it's 6. Y2 dots is the derivative of y dot. Y dot was 9t squared, so it's 18t. So in this case, what is y double prime? It's, again, y 2 dots x dot minus y dot x 2 dots over x dot to the power 3. So it is equal to y2 dots x dot. Y2 dots is 18t times x dot, which is 6t, minus y dot is 9t squared multiplied with x2 dots, which is 6 over x dot cube, which is 6t to the power 3. Simplifying this gives me y double prime should be equal to 18t times 6t. It's 18 times 6, 60, 4808, right? t squared minus 54, sorry, t squared over 216 t cubed, and that is equal 54 t squared over 216 t cubed. Simplifying 54 and 216, we got 1 over 4. T squared over t cubed, it's 1 over 4 t. T cannot be equal to 0 in this case, but y second derivative is positive for t is positive. If t positive number, 1 over 4 positive numbers, then y second derivative will be positive, and concavity will be here, upwards for t positive, from 0 to positive infinity, from 0 plus to positive infinity, open at 0, y double prime negative for t negative, concavity downwards, it's downwards. So now we can directly draw. I will draw fast because I'm running out of time in this video. So this is the x-axis, y-axis. We have stationary point at minus p0. P is a negative number. P is a non-negative number, so minus p0 is somewhere from 0 to minus infinity, because we are multiplying non-negative number times minus. So it's negative somewhere. We don't know where, but this is negative number. This is negative p, right? This is negative p0, the point stationary. Negative p, and when it is negative p, t equals 0, we said, right? Put instead of x negative p, we got t equals 0, and that's it. We have to find for x equals 0 what happens. For x equals 0, what is x? X is 3t squared minus p, 3t squared minus p. This means 3t squared equal p, right? 3t squared equals p, then t squared equal p over 3. We don't know what is that point. T equal either plus or minus. Let me draw fast. This will be the curve, right? This will be the curve, because we are out of time. This point here is radical p over 3, over radical p over radical 3. So radical p over 3. and this point will be